So in this video, we are going to discuss the polar representation of complex numbers. So let's see. Let's say the given number, complex number is z is equals to x plus iota y. So what is the real part of this? Real part is x and the imaginary part is y. Now let's see how to represent this over the plane. So this is our real axis and this is our imaginary axis. Now let's assume that x and y both are positive. So we know this is first quadrant, second, third and fourth. So if x and y both are positive, so our number, this z is equals to x plus iota y, will be in the first quadrant. So it will lie in first quadrant. So let's assume this is a required number. Okay, so this is the number x plus iota y. Now in case of Cartesian plane, we used to represent the same number by the Cartesian coordinates and representation is px comma y. Okay, now here this plane is called Argand plane because we are having real axis and the imaginary axis. So there is one point which is fixed and we call this point, this is our fixed point, and we call this point as origin. So what is the x and y component? So this is our x component and this is our y component. Okay, now here every complex number can be represented as r cos theta plus iota sin theta, but that number should be non-zero. So if you are having any non-zero complex number, then we can represent that in this form. So we need to find the r and theta. This is the only thing which is required to represent any number into this form. So this is very important because we have De Moivre's theorem which is applicable over this form. Okay, so this is important to represent the number into r cos theta plus iota sin theta form. So before doing anything, we must know what is r and what is theta. So the distance between the fixed point and the given point is called as r. So this line, black line, is r. And what is theta? Theta is the angle which this line, this r line, makes with the real axis. So this is r, this angle is the theta. So now we have to learn that how to find the value of r and theta in order to represent any complex number into this r cos theta plus iota sin theta form. So let's understand how to find this r and theta. Now let's learn how to find the value of r. So let's say given number is x plus iota y. So the value of r is actually equals to the root of real part square plus imaginary part square. So for this number, because real part is x and the imaginary part is y, so r will be under root x square plus y square. Now let's understand this with an example. So this is one example. So if z is x plus z is equals to 1 minus iota, then what is the real part? Real part is 1, and what is the imaginary part? Imaginary part is minus 1, because imaginary part used to be the number, real number, which is along with the plus iota. Can I write this as 1 plus iota into minus 1? So along with plus iota we have minus 1, so minus 1 is the imaginary part. So how to find the value of r for this complex number? By using this formula. So that will be equals to r is equals to under root 1 square plus minus 1 whole square. So answer will be under root 2. So r value is root 2. We also call this r as modulus of z. Okay, so this is how we used to find the value of r. Now let's understand how to find the value of theta. Now let's understand how to find the value of theta. So if z is equals to x plus iota y is the given number, then we know real part is x and the imaginary part is y. Before calculating the value of theta, you must know that your given number is lying in which quadrant. So let's say if x and y both are positive, then your number will lie in first quadrant. And if this is negative, x is negative and y is positive, then your number will lie in second quadrant. If your x and y both are negative, then your number will lie in third quadrant. And if your x is positive but the y is negative, that means your number is laying in the fourth quadrant. Okay, so we have two equations. So one is cos theta is equals to real part over modulus. Modulus is your r. And the second condition is sin theta is equals to imaginary part over the modulus, means y by r. So these are the two equations which should be satisfied. We have to find the value of theta in such a way that these two conditions must be satisfied. So let's understand with an example. So we have 1 minus iota. Here I know x is 1 and y is -1, and for this number we have already calculated the r in the last slide. So r is under root 2. So what is your cos theta? Cos theta is 1 by root 2. What is sin theta? Sin theta is -1 by under root 2 because y is -1 and the r is under root 2. Now your x is positive and y is negative. That means this number is laying in fourth quadrant. So I need to find the angle in fourth quadrant which will satisfy these two equations. So I know that theta is 7 pi by 4, means 315 degree. Okay. But here you may have different answers for theta, like for example theta is equals to minus pi by 4 is also correct. Okay, theta is equals to 7 pi by 4 plus 2 pi is also correct. Okay, similarly we can have multiple values. Why so? Because we know cos theta and the sin theta both are periodic function with period 2 pi. So the values of cos and sin used to repeat after 2 pi. Okay, so period is 2 pi. So that's why we used to have multiple values. We may have multiple answers for theta. To overcome this problem, we have the concept of this principal value, which we will learn in the next slide. So principal value of theta is that value which lies between minus pi to pi. Just to have the unique value of theta and to overcome this multiple values, we restrict the range of theta from minus pi to pi, and that value is called as principal value. So in the next slide, we'll learn how to find the principal value of theta. Now let's understand how to find the principal value of theta. So first step is check the quadrant where your given number is lying. Second is find the value of alpha. What is alpha? Alpha is tan inverse modulus of imaginary part and the modulus of real part. Modulus of imaginary part over the modulus of real part. Okay. And then third step would be follow this table. Okay. So here if your number is lying in the first quadrant. Okay. If this is laying in the first quadrant, then what we will have, your theta will be equals to alpha. Okay, if your angle is laying in second quadrant, then your theta will be pi minus alpha. If your theta is laying in third quadrant, then your theta will be minus pi plus alpha. And if your theta is laying in fourth quadrant, then theta will be minus of alpha. Okay, so you can follow this table, right? So now let's understand this along with example. Now let's check how to write this number into r cos theta plus iota sin theta form. So for the first one, what is the real part? Real part is 1 and imaginary part is also 1. So here what will be the r? R will be 1 square plus 1 square. So that will be root 2, right? So now what is theta? For theta, first of all, we need to find the value of alpha. So alpha used to be tan inverse. Here imaginary part, modulus of imaginary part over modulus of real part. So that will be 1 tan inverse 1, and this is 45 degree. And because x and y, real and imaginary part, both are positive here, so that means this is laying in first quadrant. Okay, first quadrant. So in first quadrant, our theta used to be alpha. So that means here theta is 45 degree. So what is the r cos theta plus iota sin theta form of this number? That is root 2 cos 45 degree plus iota sin 45 degree, means pi by 4. You may also write it like pi by 4. Okay. Now let's check for the next one. So for this, what is your real part and what is your imaginary part? Real part is -1, and what is the imaginary part? Imaginary part is also -1. So because both are negative, that means this is laying in third quadrant. Okay, third quadrant. So what is r? R is under root -1 whole square plus -1 whole square. So this is again root 2. And what will be the theta in third quadrant? So theta used to be minus pi plus alpha, right? So what is alpha? Alpha is tan inverse imaginary part modulus, that is -1, and real part modulus. So again this is tan inverse 1. So tan inverse 1 means 45 degree. Okay, but here because this is in third quadrant, so your theta will be minus pi plus 45 degree, means plus pi by 4. Okay, plus pi by 4. So what you will get? Minus 3 pi by 4. So our theta is minus 3 pi by 4. So how we'll write this number into our cos theta plus iota sin theta form? That will be under root 2 and cos minus 3 pi by 4 plus iota sin minus 3 pi by 4. Okay. Now come to the third one. So here what is the real part? Real part is 1, imaginary part is minus 1. We have already calculated the r for this, that was root 2, and because here real part is positive means x is positive, y is negative, so this is lying in which quadrant? Fourth quadrant. This is lying in fourth quadrant. Okay, so here theta used to be minus alpha. So what is tan inverse real part, imaginary part modulus over real part? So our alpha is again tan inverse 1. So alpha is again pi by 4. So but this is laying in fourth quadrant, so theta will be minus of alpha, means minus of pi by 4. So if you want to write this into this r cos theta plus iota sin theta form, that will be under root 2 cos minus pi by 4 plus iota sin minus pi by 4. Okay. So you can observe one thing, that your r, that is modulus, is same, because modulus is the distance of the point from the origin. So actually distance is same. These numbers are actually rotating. Okay, but these numbers, because modulus is same for all the numbers, these are actually distance is same. So that means this is just rotating according to the angles. Okay, so here for the fourth one, what is the real part? Real part is minus 1, and what is the imaginary part? That is 1. So this is laying in the second quadrant because x is negative and y is positive. Okay, so here theta used to be pi minus alpha, and alpha is tan inverse modulus of imaginary part and modulus of real part. So that is again tan inverse 1, means pi by 4. Okay, pi by 4 means 45 degree, and here theta will be pi minus pi by 4, that means 3 pi by 4. Okay, 3 pi by 4. So what is the r cos theta plus iota sin theta form of this? So this is equals to under root 2 cos 3 pi by 4 plus iota sin 3 pi by 4. Okay, so this is how we have written all the numbers, okay, into r cos theta plus iota sin theta form. But you need to observe one thing, that here all the values of theta are actually lying between minus pi to pi. Okay, fine. So this is how we can represent the complex number, every non-zero complex number, into this form. I hope you have understood each and everything. Thank you very much. This is from my side.